Challenger.
Welcome, guys and gals. This is your host, Frog Prince Rana, and thank you for dropping by. Today, we look at a dangerous video from quite a popular flat earth channel, DITRH, by David Weiss, titled, "It's All Perspective." Why is it a dangerous video? Well, in my opinion, and my reasoning is, on a small 3-minute video, first half is surprisingly correct. It does use some common words flat earthers do like to use, like level. Then in 1 minute, it connects that perspective to show how sun sets on a flat earth. And I know it would take me a lot longer than 1 minute to break it down and debunk it. Let's see that 1 minute. Obviously, the whole idea falls down the moment you start thinking of the whole world and maybe even think in 3D. So in this video, I'll try to show flat earthers why the first correct half doesn't apply to the second half. David didn't really say much about the size, shapes, or distances involved. Before we can start looking into any model, we need to figure some of these things out. We start by eliminating what can't be to a kind of maybe if one doesn't think too much. On the screen, you can see a basic table. There are some titles using words like large, small, far, and close. Let me explain that. A large sun far away is what we globers have calculated to be. So we are talking about over 148 million kilometers in distance, with a diameter of 1.39 million kilometers. Flat earthers often claim that the sun is much closer to Earth and not as large. Obviously, not being the reality, there is no measurement. So small and close is unknown value, but much smaller than the actual value. One quick reminder on why we can't see objects far away. Imagine a line from the top of the sun to your eye, and another line from the bottom of the sun. The angle those two lines make, well, simply put, they have to be at least the lowest angular resolution resolvable by the optics in use, may it be a camera or your eye. Back to the table. Let's start with the super easy one. Large sun close by. Now, what do you observe about the sun? We see it rising in east in the morning, sail over our head during the day, and then it sets on the west. On the Tropic of Cancer or Tropic of Capricorn, sun is directly overhead at noon once a year. Let's make it summer solstice, usually June 21st. In the northern hemisphere, at 23.5 degrees, at noon, sun is overhead. As you can see, a large sun at close distance would mean it would be sunny for people in Dhaka, Bangladesh. About 2000 kilometers away is Gujarat, India. Officially, Bangladesh sees the sunrise 30 minutes before India, but in reality, that would change depending if you're in Calcutta or Gujarat. That cannot happen with large sun close by, as the person in Gujarat would see it almost at the same time as people in Bangladesh. Next, small and far away. Those two observers on the plane is 2000 km away with a sun size of 100 km. Notice how the angular resolution at the sun 1,000 km away has a much larger angular resolution than 10,000 km. And note how for the solitary observer in the middle, initially she had a much higher angle than the other two. But as the sun moves farther away, the difference becomes narrower. This is the same as earlier example. If the middle observer is in Bangladesh, then when the sun is visible to her, it should also be visible in Gujarat. Jumping to shape for a moment. If it is a circular plane or cylindrical, well, it can't be vertical or at any other angle. If it was, when people at Bangladesh would see the front of the sun, people in Western Sahara would see the side view. So that was easy. How about horizontal? Well, it works out fine if the sun is overhead. But when it is at a distance, we'll be seeing it like this, where we would see the cylindrical shape. One shape at least solves this issue, and that is spherical. At least with this shape, regardless which angle we view it from, even in 3D space, it would still appear spherical. The same logic applies to moon. Now a quick question to flat earthers. If sun is spherical and moon is spherical, and we can do the same with other planets and stars, what is so damn special about this tiny dot we call Earth? Why should this be any different? Wait, I know. It's because we're special. God made it for us. Hurrah! Oh wow. All of a sudden, we only have two options left. It is spherical and can be large and far away, or small and close by. With large and far away, we have the same issue as small and far away. When we saw how the angular resolution changed and came closer to each other for the observers as the sun moved far away, same applies regardless the size of the sun. It is all to do with distance. Simple Pythagoras would show us how the difference in distance between sun and those three observers becomes closer and closer as the sun moves away. That leaves us with only one option remaining. This is on a flat Earth, a sun being small and close by. Quickly recapping David's illustration, obviously not drawn to scale, but we can see what he is getting at. Person A sees the sun overhead. For person B, it is around 9 AM. Then somewhere farther left from person B, we have person C, and sun is about to rise for him. You know what? This illustration sucks. Let's actually see this happening. Okay, bit better. Note that we're looking at the shape and not lighting condition. Let me explain the scenario in my world. The date is September equinox. Same as March equinox, this is the time when sun shines directly on the equator, and the length of night and day are nearly equal. Person A is at Congo, that is at 10 east. Person C is at Ecuador, that lies on 80 west. Two utterly random positions. Oh, and the person in middle, person B, is on a boat near Brazil at 35 west. Now, because I'm an ass and a gamer, one of the games I played a lot was Sid Meier's Pirate. I am the pirate lord, and as I sail towards Santa Cruz, my current location is south 23.5 degree and west 35 degree. I am at Tropic of Capricorn. So on that day, all three observers would see sun above them. Observer A would see sunrise 6 hours earlier than observer C, and 3 hours from observer B or my pirate ship. Me and observer B would see the sunrise and set at the same time. Only for me, sun would be at an angle rather than overhead. Let's see how it looks from person C when the sun is above person A. For this observer, the sun is about to rise and should be near the horizon line. Ignore the size of the sun to start with. First look at where it is from the plane. And you can see that it is way up higher from the horizon. Now suppose I got the size wrong and it is much smaller. Well, then it would not be visible at this point, which means it would disappear earlier and from higher up in sky, where in real life we see the sun to set at the horizon, which means the sun has to be lower. The camera view you're seeing is at 22mm focal length, which is same as a typical human eye viewing angle. This is where the sun is much lower. Now the size. Obviously we can see it. Well, maybe it needs to be smaller. There you go. But wait. We all heard how we can all use Nikon P1000 to bring back ship from beyond the curve. Why don't we use the same technique here? Oh sugar. From the same observer, with a focal length of 3000mm, this is what we should see. Fancy that. My guess is, nobody ever tried to zoom into a setting sun and bring it completely into view. Now if enough people subscribe, maybe one day I can get a P1000 and test it out myself. Well, let's see how it looks from Congo. This is how the sun looks overhead with 22mm focal length. We cannot increase the size, else the person at Ecuador would see it. Well, we can move it down. That would also help at other places. This looks better, right? Well, how about from Ecuador? This looks good. Maybe other things like atmospheric refraction gets in the way to make the sun hidden at that point. Great. Oh, one more thing. Unless mentioned otherwise, all camera is emulating normal human eye with 22mm focal length. How about from boat near Brazil? Oh dear, oh dear. Over here, we are 3 hours behind Congo. That is not a 9 in the morning sun. Way too low at the horizon for the day specified. Never mind. Let's rewind time, for I am the destructor of thermodynamics. Having the sun above Congo and let it roll. You're seeing the sun orbit at an orthogonal view. At September equinox, sun is above equator, and my sun tries to follow that line. Yes, I appreciate it is a bit harder to see the sun, but remember, if we made it any larger, it would be visible from places it should not be. We can make it larger and push it higher, but then it would disappear from view long higher than horizon. With our observation, this is what really the size comes down to. Now for the views. First panel shows us the sun tracked from Congo. Yes, I do realize we get to see the damn sun throughout the whole orbit. Again, don't blame me. I'm only modeling from what we have been told by some flat earthers like David. Second panel, or top right, is boat from Brazil, which is 3 hours behind Congo. Third panel, or bottom left, is view from equator, which is 6 hours behind Congo. Finally, panel showing view from my pirate ship, Globe Earth. The two we should really be looking at are the boats. Both should experience the same day length. Look out for midday over there. I will just let it run for a little while so you can see what is going on. Now some freeze frames. This is when sun is above Congo, equator at 6 am. At both boats, it's around 9 am. Note how the sun appears almost the same position as from Ecuador, though it should be ahead by 3 hours. Next is sun above boat near Brazil. So 3 am at Congo and 9 am at Ecuador. From Congo, it appears at the height where it would disappear, according to David. But my pirate ship gets the blunt of it. It is supposed to be midday for me. So I'm expecting a view similar to boat in Brazil, with the sun a little lower down on screen. Finally, sun above equator. So boats are at 3 PM and sun should be setting at Congo. Same deal from the boat, the sun appear too low. How about reality? Well, it was surprisingly easy. The only difficult part was to scale the immense distance and diameter of Sun within a 3D modeling software. Please note that there is no atmosphere in the model. The cameras are quite high up from ground. On top left, you can see the full Earth rotation. Sunlight is coming from the bottom right, as you can see from the shadow. Just so there is no cheating involved, 4 colored bars would rotate with Earth. These are 4 viewpoints, each perpendicular to nearest bar and at the equator. All those cameras are tracking the Sun. Thus, when it is behind the Earth, the camera would be looking towards the ground. I could have gone more into it, showing how the light would actually behave to light up different continents. Well, if a viewer would like to see it, please drop a comment. This is just to illustrate that it is not all about perspective. There is something called obstruction, or as we globally call it, curvature. Back to our starting table. Oh dear. We don't have any options left on flat Earth to explain the Sun. And once, if someone can explain the basic movement of Sun, well, then there are moon motion, eclipse, lunar phases, tides, and seasons left to explain. I'm sure I have missed a bunch back there. I honestly have no clue how a channel like DITRH has over 55,000 subscribers. Are they all just as stupid as David? Well, this is where I'll end this video. Thank you so much for watching and sticking till the end. If you have enjoyed this content, please give this video a like, comment, and even share and recommend my channel to your friends. All those helps. If you haven't already subscribed, it would be much appreciated if you do. It will help my tiny little channel grow and help bringing more contents to you. Thanks once again, wherever you are. Have a safe day. Signing off.